Hey, what's up guys? On today's video, we are going to talk about parallel loops. Just quick remind from previous video, we have talked about goroutine and the channels. So basically, goroutine is just a small version of thread, and it's managed by Go runtime. And on today's video, we are going to use goroutine and the channels to program asynchronous. So let's say if we are required to create a function to create a thumbnail for files, and the user gonna passing a slice with the file name, and we need to loop through the file slice and to create a thumbnail. So we have a package called thumbnail here. We just assume we have that package. It's not working now, but we just assume, and we can call the method called image file. That's gonna help to create a thumbnail. That's gonna create a thumbnail. So if we're gonna create on for first version, we can do that. We can loop through the slice, and for each of the file name, we're gonna pass into image file function that will create a thumbnail. That's our first version. But as you can see, if there is 1,000 of files, and we need to loop that through, and this is like a synchronous function, and it's gonna take a long time to do that, because for synchronous function, it's like this, you have to do that in the procedures like 1, 2, 3. You need to do that in the order. So we need to do that for the asynchronous way. So for in order to do the asynchronous way, right? We same thing here. We create a function. Let's say that's our second version. We say make thumbnail 2, and then that passing the file name as well, with the slice. And I'm gonna loop that through, and instead of doing that one by one, right? We call that function with the goroutine. So basically, we put that in a black box. So if that file name, it has like we have 10 file name in a slice, so that's gonna fire the 10 goroutines, and it's gonna work. It's gonna run behind the scene. Okay, that looks good. It's gonna save a lot of time, because this is like a asynchronous way. So we can fire the goroutine like at the same time. It's gonna work. It's gonna work like at the same time. So that looks good so far. It can save a lot of time. And in order, so we have that in a black box, and we also required to get the data from the goroutine. So in order to communicate between goroutine, we need to have a channel. So we're gonna create our third version here. We say make thumbnail 3. Same thing, we pass the slice of file name, and we create a channel here. So we create a channel. So we loop through the slice, and we have a goroutine here, same as previous one. The different thing is like when we have an error come out here, when we create a thumbnail, right? It might have an error. When there's error, you need to pass that to the channel. And here that's the loop through the file name as well, and it will receive if there's error, or is there error or not error here. Just a quick remind here. On here, that's the loop, right? That's the self-involved function. we need to pass in the param f here, because this is shared. This is like same variable, and that is the if we don't do it on that way, if we like this, we just pass in here in this self-invoke function, and that's gonna it's gonna use the last file name because it share the memory, because we have only one variable. So we have to pass in this prompt. So basically it copy the value and pass in here, so we can make sure the it's like this is what we actually want. And okay, for here, and now we are able, and now for the goroutine, we are able to get the message from goroutine. Okay, so we need to handle the error. If there's error, we need to log that out. So we need to improve this function, and we improve one called make thumbnail full. Same thing, we have a channel, and we loop through the slides, and we take it gonna put the message into the channel, and on here that loop through the file, and listen to the channel, and you need to be very careful here. Okay, so when you return an error, right? So this function has been returned, but if we have like a 10 file name in a slice, so if we have an error on first one, right? We'll have an error on first one, but we fire like a 10 goroutines, and we receive the first goroutine, and it get returned, and this function get returned, but there is the 9 goroutine behind the scene. They still running, and they still trying to send the message to the channel, but the channel has been returned. No one receiving the message from channel, and that will cause the goroutine leak, because it never gonna get recycled, because we have not receiver from channel anymore, because this is the error and get returned. And you just need to be very careful about that. We need to make sure we have receiver, or we need to make sure there's a buffer channel in order to get avoid of goroutine leak. Okay, so let's fix that problem with the another version. Make thumbnail 5. So still same thing here. So we make a channel. We just define a channel that from previous channel they only receive error, but on this channel we receive thumbnail thumb file and error. And the different thing is this is a buffer channel, because we know the length. We passing the size, the length for the channel. So it means that channel has we don't need to wait for the receiver to receive, and we have like a buffer size of the file name. And on here, same thing. We loop through the file name, and whatever happens, we're gonna send. We're gonna get the thumbnail, and we're gonna send that to channel. And if there's error, right, and we're gonna return that function. That function gonna get returned. But the good thing is, because this is buffer channel, and the goroutine behind the scene, right? Even this function get returned, and the goroutine behind the scene, they can still send data to the channel. Once goroutine has finished sending the data to channel, the goroutine can be recycled, and the channel can be recycled too, as there's not receivers anymore. So this is like a final version of the make thumbnail. And so we have covered from like a synchronous function, and we improve that, we optimize it to asynchronous, and after asynchronous we handle we handle the we communicate, we use channel to send data between channel to get the message from goroutine. And we also check if there's error from goroutine. And for the final version, we solve the problem with goroutine leak. Okay, so this is like a parallel loop, and we have another scenario is from previous example, we have the file name we have with that passing as a slice, right? And we can use the slice length as a buffer size for channel. We have another scenario is we don't know the size of slice. What if user is not passing slice? Like what if we don't know the size? How can we get avoid with the goroutine leak? Okay, so we have another way to do that. For this example, instead of the param is a slice, we have param of channel. So, and we don't know the size of channel. We don't know like how many like message gonna send in the channel. So we can't really do the buffer channel. So another way we can do with we use the WaitGroup. So basically we have a package, that's a built-in package called sync. We have a WaitGroup, and on the WaitGroup we have like this. We have a method called add, and we have a method called done. So add is like a counter, like you add one. Basically you have a counter, right? It add one, and then your counter gonna be like you add one, and the done is like the -1. You can think of this as like a done. So this is, you can say this is there's a global counter here, and then you add one, and that's -1. When the counter is 0, right, and that listen to when the counter is 0, that's gonna close. They're gonna close the channel. So I just explained the WaitGroup, and so let's look through this function. We have a size here, that's the channel, and then we have a WaitGroup. That's the pretty similar compared to previous one. That's in the goroutine. We get the thumbnail, and then we get the size, we get the info, we get the size, and then we can pass the size to the channel here. Okay, so we put the WaitGroup in WaitGroup wait function, and then close the channel function in another goroutine that basically that listen to if there is a WaitGroup is 0. And we have a listener. Basically, this is a channel. We listen to the channel if anything passing to the channel like this. That's in the goroutine, and then we pass in the size to a channel. So basically, that listen to the channel here, and then that add the size. So, and that add the size, that's gonna return to the total of the file size. So in order to call this function, let's say we create a channel called file names, and we use another goroutine to call. We use another goroutine here. So we have different function that's gonna be called before this function is finished. So we have a slice here with the like a file name, file path, and then we're gonna loop through the file name, and then we're gonna send the file name. We send the file name to the channel, the file names to the channel, and this function that listens to the channel if anything passing to the channel, and if there's something passing the channel, it's gonna work out the size. It's still gonna listen. It's gonna wait for the size until we call this function. Until we close the channel. When that is closed, right, and it stop, and it listens, there's a 0 because we close the channel, and that listen, that gonna close the channel in the make thumbnail as well, and I'm gonna return the total, and we were able to get the total back. So that's pretty much it for parallel loops. It's a little bit complicated compared to synchronous function. So let me just summary it up. So so we have two different scenarios. The one is like we know the length of the parallel loop, so we can use buffer channel to do that, to deal with that. And in another hand is that if we don't know the length, and if we're receiving a channel, we can listen to the channel. We can use the WaitGroup to handle that. We make sure every goroutine has been handled, and that need to be closed, and the channel need to be closed properly. And the goroutine, you need to make sure in the goroutine, the channel has we need to make sure the channel receive everything in the goroutine. We need to avoid the goroutine leak. Okay, so that's two different scenarios for parallel loops. Okay, that's the video for today. I'll see you guys on next video. Bye for now.